Hello everyone, today we're going to be solving limiting reactant problems. I got a couple problems right here and one on the next slide, and we'll just go through each A, B, and C, and I'll try and give you my thought process behind each one so you guys can get a better understanding of limiting reactants. We'll start with this first one. What we're going to need for all of these is the balanced chemical equation, which is going to be 2Al plus 3Cl2 creates 2 aluminum chloride. The question's asking, reaction consisting of aluminum and chloride are combined to make aluminum chloride. For A, given 3.01 times 10 to the 23 atoms of aluminum and 5.02 times 10 to the 23 atoms of chlorine, determine the limiting reactant. So immediately we see that we're dealing with atoms, and we need to get some moles for limiting reactant. So what we're going to have to do is do 3.01 times 10 to the 23 atoms, and we'll just put that on top, because whenever we're given something, we're going to put that on top. And then we're going to multiply it. And we need to get this to moles. So we need to use Avogadro's number, which is going to be 6.02 times 10 to the 23 atoms per mole. In this case, we need to flip it to get mole on the top. So we'll have 1 mole and then 6.02 times 10 to the 23 atoms. And then that will give us 0.5 moles. And that will be of, and this was of aluminum. So this gives us moles of aluminum. And then this next one is going to be of chloride. So we need to do 5.02 times 10 to the 23 atoms of chloride. I'll put that over 1. And then we just need to multiply that, same as before, by 6.02 times 10 to the 23 atoms. That's going to give us an answer in moles, which will be 0.834 moles. So initially you might think, oh, the answer is just going to be this one because this is what has less, aluminum, right? And then this one's chloride. But the fact of the matter is that can't be right because we still haven't used the balanced chemical equation in this scenario. We need to divide, so here's what we'll do. We'll bring this over, and we need to do 0.5 moles of aluminum over, and then we grab this guy, and we bring him here, and we do 2 moles of aluminum, and that will give us our final kind of mole value, which in this case would be 0.25 moles. And so from here, and that'll be 0.25 moles of aluminum to be exact. And then we also have to do that for the other one, which will be 0.834 moles, and that'll be of chloride. And that's coming from this guy. And then we need to find the moles of chloride, which is 3 right here. And immediately I can say that it'll probably be closer to 0.33, but we'll just do the math really quick. Just give me 1 second. So 0.834 divided by 3, that's just going to equal 0.278 moles of chloride. And then from here you can see that aluminum will be your limiting reactant for the atoms value. So we can erase all of this and just go ahead and write that the answer for this one, for A, so A's answer is going to be aluminum. Aluminum as the limiting reactant because it had a lower mole value when comparing the two with the balanced equation, also with using the atoms of aluminum and then dividing them by Avogadro's number to get you that value. And then that value was 0.25 moles. All right, let's move on to the next one. This one's dealing with molar mass. So we have part B, and it says determine the limiting reactant with 10 grams of aluminum and 35.5 grams of Cl2. So I'll just take a second, pause, try and just do this one on your own. I'll give you a quick hint. Use the molar mass of aluminum and chloride, and then use the grams that are given. I'll give you a second. You can pause the video right here. All right, now you're back. So this one's using 10 grams, and we already have the balanced equation above, so we can just hop right into it. We need to know the molar mass of aluminum, which is going to be basically 27 grams per mole, and then the molar mass of chloride is going to be 35.5 grams per mole, So from here, we'll start with aluminum, and it says we're given 10 grams of aluminum. So we'll put that over 1, and then we'll multiply. We need to get to a mole value, so we're going to use 27 grams on the bottom, and we'll have 1 mole on top. And then that, we'll just do 10 divided by 27, gives us 0.37 moles, and that's of aluminum. And then we'll also hop into and do the chloride one, which will just be 35.5 grams Cl2. Make sure to label. And then we'll have 1 mole on top, and we'll have 35.5 grams on the bottom. And that'll actually just give us 1 mole of Cl2. Once again, you're not done yet. You need to use the balanced chemical equation to find your true limiting reactant. So we'll start with aluminum on top, using the 0.37. Let me make this black. So 0.37 moles of aluminum on top, and then on bottom we'll have 2 moles of aluminum. And then that will just give you a value of 0.185 moles. Okay, so circle this in red. And then we have this other one, which is chloride. So we'll have 1 mole of chloride over 3. And pretty simple, that'll just be 0.33. So we'll have 0.33 moles of Cl2, and this is of aluminum. So in this case, once again, aluminum will be our limiting reactant with 0.185 moles. So let's go ahead and erase this. So 0.185 moles of Al, and that's going to be our limiting reactant. Alright, pretty simple. We'll just hop on over to this last one. So this one, we're given the moles. So all we're going to have to do for this is just look at what the problem gave us. It gave us 0.75 moles for aluminum. And then we just have to divide that by the moles of aluminum. And in this case, it's just going to be 2. Because that's just coming from this equation right there. And so that'll just give us a value probably close to 0.5. 0.375 moles of aluminum. And then on the other side, we're going to have to do chloride, which will just be 1 mole over 3. And that's just going to give us, and these are Cl2, and that'll just give us 0.33. So in this case, chloride will be our limiting reactant. So pretty simple. So 0.33 moles of chloride is our limiting reactant. Okay, pretty simple. So for A, it'll just be aluminum. For B, it'll be aluminum. And then for C, it will be chloride. And you always have to make sure to use the balanced chemical equation. For this problem, we're given a propane combustion reaction consisting of C3H8 and O2 that are combined to make carbon dioxide and water. So we have the balanced chemical equation right here. And we can just make sure we have equal amounts. We have 10 here, and we have 6, and good. That's good, and hydrogen's good. So yeah, we have a balanced chemical equation right there. So this is very similar to the last one. We're going to start with our molecules. So we're going to use molecules this time instead of atoms. Same thing, exact same thing. So we're given 6.02, and we need to know Avogadro's number, which is this. It's going to be atoms divided by moles. But for this one, we're going to do 6.02 times 10 to the 23 molecules. And this is of C3H8. Set that over 1, and then you need to multiply it to get moles on top. And it's just going to be 6.02 times 10 to the 23 molecules of just molecules, because that's Avogadro's number. And in this case, you're just going to get, pretty simple, 1 mole of C3H8. And then for the O2, we have to do 3.01 times 10 to the 23 moles, or molecules of O2. Set that over 1. And then we just need to do 1 mole divided by 6.02 times 10 to the 23 molecules. And that just gives us 0.5 moles of O2. And from here, we just need to use a balanced chemical equation. So we'll do 1 mole C3H8 divided by 1 mole C3H8, just giving us, pretty simple, 1 mole, right? And that's for C3H8. And then for O2, we're going to have 0.5 moles of O2 divided by 5 moles of O2. And once again, just going to be 1 mole of O2. So in this case, what's going to be our limiting reactant? 1 mole of C3H8 or 1 mole of O2? Well, they're both the same, so it's going to be neither. They're both the exact same, so neither of them limit. They both are steady state. So the reaction will proceed as follows. And then now we're going to have to do the molar mass version of this problem. So first we need to know the molar mass of C3H8, which is just going to be, and that's just propane, right? And so that's just going to be 44 grams per mole. And then the molar mass of O2 is just going to be 16 times 2, which will be 32 grams per mole. So we're going to have to start with C3H8, which gives 44.1 grams of C3H8 over 1. And we need to get this to moles, so we'll use molar mass. And the molar mass of C3H8 is 44. So then we're going to put that on the bottom, 44 grams, and that just gives us 1 mole C3H8. And then we have O2, and we're given 160 grams of O2. We set that over 1. We need to multiply this by the molar mass, so we have 1 mole, and we have 32 grams on the bottom. And that will give us a value, I believe, of 5. So that'll be 5 moles of O2. And you guessed it, once again, we're just going to divide by our balanced equation, and that's just going to be 1 mole C3H8, giving us 1 mole again. And then it's just going to be 5 moles, again, dividing, because we're using this right here. And that will give us 1 mole. So, try and take a guess what the limiting reactant of part B is. If you guessed neither, you are correct. It is neither. So, pretty simple. Not too bad at all. And now we'll do the last one, where we're just given the plain moles. So we have moles of C3H8. So that's just going to be like 2 moles. And then we have 8 moles of O2. So we'll start with C3H8. We have 2 moles of C3H8. We need to divide that by the balanced chemical equation, which is just 1 mole of C3H8. We got that from right here. Right here. Just making sure you guys got that engraved in your head. We need to use the balanced chemical equation. And then we just use C3H8. We get 2 moles of C3H8. And then we also have to do the same for oxygen, where we have 8 moles of O2. And we have to divide by 5 moles of O2, which I also got from the balanced chemical equation right here. Okay, and that value will just be 8 divided by 5, giving us 1.6 moles. Go ahead and guess which is our limiting reactant in this problem. If you guessed O2, you were correct, because it is the smaller mole amount. Even though it has more moles in the balanced chemical equation, the amount we're given in the problem is less. Also, you have to recognize the molar mass of O2 is lower than C3H8, which probably has a part to play. And there's just the sheer amount of, like there being 5 moles of O2 in the balanced chemical equation will also play a part in it being the limiting reactant. So yeah, that's it for today, guys. I hope you were able to understand and get a better grasp of limiting reactants. If you have any questions, go ahead and drop them in the comments below. If you enjoyed the video, subscribe and let me know what you guys want me to teach you next. Have a great rest of your day. Bye.